Hi everyone, today we are going to start reviewing chapter 7. We have done this already, so this should just be a review. We're going to do the multiplication properties of exponents. Let's do a quick review. What about product of powers? So if I had x to the third power times x to the fourth power, that's the same as x times x times x. Then I'm multiplying that by x times x times x times x, which gives me x to the seventh power, which, as you can see, is the sum of 3 and 4. So when I'm multiplying powers with the same base, I just add my exponents. Okay, what about a power to a power? This means x to the third power times x to the third power. Again, x times x times x, but this time I'm multiplying by x times x times x, because I'm multiplying it by itself. And this will give me 1, 2, 3, 4, 5, 6 x's, so x to the sixth power. So when I raise a power to a power, I multiply the exponents. 3 times 2 is 6. What about a product to a power? What if I'm raising xy to the third power? Well, that means xy times xy times xy, which gives me, if I rearrange it, x times x times x and y times y times y, or x to the third power and y to the third power. So when I raise a product to a power, I have to raise each of the factors to that same power. Let's do some examples. I have 3x to the third power, and I'm multiplying that by x to the negative 7 power and x to the 10th power. Well, these have a hidden coefficient of 1. 3 times 1 times 1 is just going to give me 3. But let's add these exponents. 3 plus negative 7 gives me a negative 4, plus 10 gives me a positive 6. Oops, I forgot my x. 3x to the 6th power. I didn't need that one there. 3x to the 6th power. Let's try another one. I have 3h to the third power, and I'm raising that whole thing, that whole product, to the third power. That means I have to raise my 3 to the third power. And then I have a power to a power, which means I multiply these powers, which give me h to the 9th power. I can simplify that further because I know what 3 to the third power is. That is 27 times h to the 9th power. Couple more examples. I have 3x to the second power, and I'm multiplying that times x to the 11th power. Again, I need to raise my 3 to the second power and my x to the second power. So 3 to the second power, x to the second power, and I'm multiplying that by x to the 11th power. Multiplying powers with the same base, I add those exponents. 2 plus 11 is 13. So 3 to the second power times x to the 13th power. And again, I can simplify that because 3 to the second power is 9x to the 13th power. Now I want you to pay attention here because here my 2a is being raised to the third power. But in this one, the exponent's on the inside. It's only my a that's raised to the negative 2 power. So I have 2 to the third power times a to the third power times 3 times a to the negative 2 power. Oh, 2 to the third power is 8 times a to the third power times 3 times a to the negative 2 power. I wanted to just rewrite that so we can see everything. 8 times 3, 24. A to the third power, a to the negative 2 power. Remember, I add my exponents, so it will leave me with a to the first power, which I could write the 1, but you don't have to when the exponent's 1. Just 24a. Another power to a power. I have x to the negative 2 power, x to the raised to the negative 4 power. I got to multiply those. Negative 2 times negative 4 is going to give me a positive 8. Then I have y to the third power, and I have to raise that to the negative 4 power. 3 times negative 4 will give me y to the negative 12. But I can simplify that further because I have that negative exponent, which means I can take this and move it downstairs to make it a positive exponent. So that will be x to the 8th power over y to the 12th power. Next example, I have x to the 5th power, x to the negative 9. Let's add those exponents. 5 and negative 9 will give me x to the negative 4 power. Again, when I have that negative exponent, I can move it downstairs. But in this case, I'm going to have to leave that invisible coefficient of 1 upstairs. So I'm going to have 1x to the 4th power. I can't just leave nothing in the numerator. They're getting a little bit trickier. Let's simplify what we can first. I have a to the 3rd power, b to the 3rd power. Do you remember anything to the 0 power is just 1? So I can ignore that. And then I have b to the negative 5 power. Okay, since I only have the 1a, I'm going to leave a to the 3rd power. Then I have 3 and negative 5. That will leave me with b to the negative 2 power, which can go downstairs. A to the 3rd power over b to the 2nd power. Next example. Now you'll notice that none of these exponents are being raised to a power. So I can just think of this as just multiplication all the way across. First thing I'm going to pay attention to is that coefficient of negative 3. I'm going to put that out front. Now I have x to the 4th power, x to the, there's an invisible 1 power here. 4 plus 1 gives me x to the 5th power. I'm going to change colors for my y's just so it's easier to see. Here I have y to the 1st power, y to the 3rd power, so I'm at y to the 4th, and then negative 7. Well, negative 7 plus 3 plus 1 will give me y to the negative 3. Because 1 plus 3 is 4. 4 plus negative 7 is negative 3. That y can move downstairs, which will leave me with negative 3x to the 5th power. Now, I want you to pay attention to that. My coefficient is a negative number. It is not a negative exponent. It will stay upstairs. My y, however, will move downstairs and become a positive 3. That's it. Have a great day. See you soon.